Assalamualaikum. My name is Nur Nadira binti Muhammad Nasir. I am mechanical engineering student. I'm going to talk the introduction about the laminar flow in tubes in entrance region. Here is the introduction. Laminar flow in tubes. Entrance region. Consider a fluid entering a circular pipe at a uniform velocity. Because of the no-slip condition, the fluid particles in the layer in contact with the wall of the pipe come to a complete stop. This layer also causes the fluid particles in the adjacent layers to slow down gradually as a result of friction. To make up for the velocity reduction, the velocity of the fluid at the midsection of the pipe has to increase to keep the mass flow rate through the pipe constant.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ammar Al-Amoudi. I'm a mechanical engineering student. I'm going to explain about the fluid velocity inside the tube. Assalamualaikum warahmatullahi wabarakatuh. I'm going to explain about the velocity, the fluid velocity inside the tube. Firstly, you have to know that it's like a process. Two process from here till this part, we call it entrance region, and from here to here, fully developed region. In the beginning, the fluid, it will enter from this side at constant velocity. The shape, it will be the same, equal at all the sides till it reach the second, like we can say the second part. It will change a little bit till it reach the last part of the entrance region. The last part in the entrance region, we can say this is the V max, the velocity max for the fluid. And this part, we can say it's 0, because why here is 0 and here is V max? Because here at this part there's no reaction. But here, there's reaction from the wall. It affects the velocity fluid at this 2 point, 1 and 2. When it goes from the entrance region, it will enter to fully developed region, and this is the fully developed. Because of that, they call it at this process fully developed region.
My name is Amin Rashid. I'm from mechanical engineering. I will explain about entry length in entry region from laminar flow. Laminar flow in tubes entrance region entry length. Hydrodynamic entry length usually taken to be the distance from pipe entrance to where the wall shear stress achieve 2% of fully developed value approximately. In laminar flow, we have 0.05 times Reynolds number of flow times diameter of pipe. The entry line is where starting from this part to this part before become fully developed flow region.
Hi, my name is Chu Ken, and I am a mechanical engineering student, and today I'm going to talk about the thermal development in a tube and the list of formula used in the calculation. This is the thermal development in a tube, and the region of flow over which the thermal boundary layer develops and reach the tube center is called the thermal entrance region. The region beyond the thermal entrance region is called the thermal fully developed region. And these are the common terms used in the table. And thermal entrance region is the region of flow over which the thermal boundary layer develops and reaches the tube center. Thermal entry length is the length of the region. Thermally developing flow is the flow in the thermal entrance region, and this region is where the temperature profile develops. Fully developed flow is the region in which the flow is both hydrodynamically and thermally developed. These are the formulas. This is the list of formula used in this part. For the bulk mean fluid temperature, the temperature of bulk is equals to temperature of mean inlet. plus the temperature of mean of the outlet and divide by 2. And for the surface heat flux is equal to the heat transfer coefficient times the temperature of surface minus the temperature of mean. The surface heat flux is usually higher in the entrance region of the tube, and the effect of entrance region is always to increase the average friction factor and heat transfer coefficient for the entire tube.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdullah bin Abdul Hamid. I'm an engineering student. I will talk about the summary for this topic, that laminar flow in tube interregion. I hope your guys will enjoy. We'll talk about the summary. Firstly, internal flow is characterized by the fluid being completely confined by the inner surface of the tube. The flow in a tube is laminar. The Reynolds number must be below 2300. And then the length of the region from the tube inlet to the point at which the flow becomes fully developed is the hydrodynamic entry length. The region beyond the entrance region in which the velocity profile is fully developed is the hydrodynamically fully developed region. The length of the region of flow over which the thermal boundary layer develops and reach the tube center is the thermal entry length. The region is which the flow is both hydrodynamically and thermally developed is the fully developed flow region. For the last from the topic, we can conclude that although the theory of fluid flow is reasonably well understood, theoretically solutions are obtained only for a few simple cases, such as fully developed laminar flow in a circular pipe. Therefore, we must rely on experimental results and empirical relation for most fluid flow problems, rather than closed from any analytical solution.